Material Requirements Planning (MRP) is a time-phased planning system designed to determine what materials are required, how much is needed, and when those materials must be available to support production schedules. MRP translates the Master Production Schedule (MPS) into detailed component and raw material requirements by using product structure information and inventory records. It is particularly effective in manufacturing environments characterized by dependent demand, complex product structures, numerous components, and variable production schedules. Service parts can also be managed within MRP systems when replacement components, maintenance materials, or spare parts require structured planning and inventory control. By coordinating material availability with production requirements, MRP supports efficient operations, improved customer service, and effective inventory management. MRP is generally favored in environments where products contain multiple levels of components and where demand for materials is dependent on planned production. Make-to-stock, assemble-to-order, make-to-order, and certain engineer-to-order environments often benefit from MRP because of the complexity of coordinating material flows. Although lean systems emphasize pull replenishment and reduced inventory, MRP continues to provide value by supporting long-term planning, supplier communication, and visibility into future material requirements. Organizations frequently combine lean execution methods with MRP planning capabilities, allowing short-term operations to remain demand-driven while maintaining longer-term visibility into material and capacity needs. This integration strengthens supply chain coordination and supplier collaboration. Effective MRP implementation requires careful design of planning horizons and time buckets. The planning horizon must be long enough to cover cumulative lead times, procurement requirements, production activities, and supplier commitments. Time buckets divide the planning horizon into manageable intervals, such as days, weeks, or months. Shorter time buckets provide greater detail and responsiveness, while longer buckets simplify planning but may reduce accuracy. Some organizations utilize bucketless systems that continuously update requirements based on real-time transactions and changing conditions. Selecting appropriate planning horizons and time structures ensures that MRP outputs remain relevant, actionable, and aligned with organizational planning needs while supporting both short-range execution and long-range strategic planning. The quality of MRP outputs depends heavily on the accuracy of its inputs and supporting data sources. Three primary inputs drive the MRP process: the Master Production Schedule, bills of material (BOMs), and inventory records. Additional inputs include purchasing information, lead times, planning parameters, engineering data, and supplier constraints. Item master records contain critical planning information, such as lead times, order policies, lot sizing rules, safety stock levels, and sourcing details. Because MRP calculations rely on this information, organizations must continuously review, validate, and maintain data accuracy. Poor data quality can result in shortages, excess inventory, incorrect schedules, and ineffective planning decisions that negatively impact operational performance. Bills of material serve as the foundation for multi-level material planning within MRP systems. A BOM defines the parent-child relationships among finished products, assemblies, subassemblies, and components. MRP uses BOM structures to explode requirements from higher-level items into detailed lower-level material requirements. Engineering data associated with BOMs must be accurate and current to ensure planning effectiveness. Where used reports identify all products that utilize a specific component, supporting engineering changes and inventory management activities. Pegging reports trace requirements back to their originating demand source, helping planners understand why specific materials are required. These tools improve visibility, support decision-making, and strengthen coordination among engineering, planning, procurement, and manufacturing functions. MRP utilizes various BOM structures to support both short-range and long-range planning activities while addressing supplier and organizational constraints. Single-level BOMs focus on immediate parent-child relationships, whereas multi-level BOMs support complex product structures involving numerous assembly levels. Through time phase calculations, MRP determines planned order releases and planned order receipts that align material availability with production requirements. These outputs help organizations create feasible material plans that support customer demand while considering supplier lead times, minimum order quantities, capacity limitations, and inventory objectives. By integrating MPS information, BOM structures, inventory records, and planning parameters, MRP provides a comprehensive framework for managing material requirements and supporting effective manufacturing operations across diverse business environments.